Hello, my name is John Massaria, and today for my Python 256 project, I wanted to kind of dive deep into sports analytics and give my first go at trying to scrape the web for player data on my own. And to do that, I wanted to use a new API, which we have never discussed in class, which was the NBA API. I know we briefly touched on the ESPN API, which is a very similar idea because ESPN does have NBA data on it, but I wanted to try getting the data directly from the NBA player website. And to do that, the first thing we must do is import all of our packages, such as the NBA player API itself, along with pandas, JSON, request, matplotlib, which we'll use later, and matplotlib.pyplot. And then the next thing we must do is from the NBA website, we must load in all the teams and the players. There are 30 teams in the NBA. We must load in all of those, and then we have to load in each of the players on each of those rosters in the league. And to do that, we have to get a team ID along with a player ID for each players. And down below here, you can see I was testing for the Orlando Magic along with Damian Lillard. You can see both of their player IDs are here and here, respectfully. And then after that, we have to create a JSON request for the specific player, which we are looking at. And the first one I wanted to look at was Stephen Curry and his second MVP season with the Golden State Warriors, where he won unanimous MVP. And after that, we have to load all of our data into a Python dictionary and draw relevant data from that dictionary. In doing that, we create the headers and rows of the data frame, which we are creating using pandas, which we learned in class. And here are all the columns to the Curry's data frame, which include player name, shot type, shot zone range, shot attempted flag, seconds remaining, team ID, team name, and so on. And then from there, that's when we begin to create the basketball court itself for the visualization, which we are creating. And the first thing we have to do is plot the dimensions of an actual basketball court into Python. And doing that with some help from GitHub, I was able to find a plot of a basketball court that is the exact measurements of an NBA basketball court in Python. And once we input all of those plot points, we are able to input our data for Stephen Curry on the court, as you see here. And then we get our first visualization. And so this is Stephen Curry's 2015-2016 regular season, where he won his second MVP, first unanimous MVP. And from the visualization, we're able to see areas of which where he scored in extremely high volume with a great field goal percentage, which is the percentage of which he makes his shot attempts. And you could see during his MVP season, he scored mostly in the paint and from the outside perimeter, not too much in the mid-range area. And then the next player I wanted to look at was Russell Westbrook, where he almost averaged a triple-double during his MVP season. And some of the things that we have to change when looking at different players on different teams is we have to change the team ID, the player ID, the season in which we are looking at, and whether or not we want to look at the regular season or the playoffs. And then same thing for the Westbrook data, we have to change the names of the data frames in the pandas document, which we are using, and we have to change the name in the columns as well. Everything for the basketball court remains the same. The only difference is when we add the visualizations for where Russell Westbrook made most of his shots, we have to change his name in the title, the season, and the data points. We have to change to Russell Westbrook rather than Stephen Curry, for example. And what's different about this diagram compared to the last one is you could see Russell Westbrook shoots a lot more mid-ranges than Steph Curry and drastically less three-pointers and from not as deep of a distance. because Steph Curry is the greatest basketball shooter of all time, and there's no competing with him. And Russell Westbrook tends to dunk the ball a lot more, so you could see more scoring in the low, mid-range to paint area as well for him. And then the third MVP I wanted to take a look at was James Harden, which we had to change to the Houston Rockets, James Harden 2017-2018 season, regular season. And then same thing, keep the basketball court it's the same, but change all of the data itself within the diagram to represent James Harden and the shots he took over the 2017-2018 NBA season. And you could see James Harden shoots an extreme amount of threes from the top of the key area and from the left of the key side because he's a lefty. And then for those three, they're guards. So like from a quick glance, you may not see the differences, but here come the three big men that took over the league over the next 3 to 4 years. And the first one is Giannis. You could see that Giannis Antetokounmpo shot almost 0 3-pointers in his first MVP season, and almost all of his points came from inside the 3-point arc. The same goes for his second MVP season. He actually was able to increase the amount of 3-point shooting around the court significantly, including a vast amount from the top of the key. And then Nikola Jokic, our first big man that we've really seen dominate from all three levels. He scores a lot in the paint, a lot in the mid-range, and an extreme amount from three as well for a big man. We could see over his second MVP season, he still continued to shoot from all three levels extremely well, which led to our current MVP, Joel Embiid, which we've seen dominate the mid-range game and take some of his scoring to the 3-point level as well. But given this project, I was able to really identify different levels of scoring between NBA players and get to work with different analysis tools such as the NBA stats website and the API that they give to us to use. I had an extremely fun time with this project, and I hope to crack into the world of sports analytics after this moment. Thank you, Professor, for an awesome semester. And that's all I got to say. Thank you.